Hello guys, my name is Tu. So for this video I'll be demonstrating on how can we hook up MCD or NX Mechatronics Concept Designer with external signals through the TCP interface. So I have a simple robotic arm over here. So if I try to show you the definitions, basically it is just having some simple rigid bodies, and we have the joints defined and also positions. So what should be done to hook up with the TCP connections? So first of all, I have defined what I want the TCP external signal to do is to have the external signal to drive the tool center point. So for example, the tool center point is over here. So the TCP external signal will tell me where this point should be at the current time. So let me just quickly show you the inverse kinematics. So I would need to select this object to listen to a specific point. For example, here, and this point is mapped to an external signals. So this point is actually driven by the external signals. So how is it done? So we'll be looking at the signal adapters. Okay, so this will be the definition, the inverse kinematics definitions, and we are bringing in position X, Y, and Z. Definitely we can bring in the alpha, beta, and gamma, but for this case we are just going to map these 3 points. So for these 3 parameters of the point, this refers to the Cartesian coordinates of the point, and we are going to map the signals with incoming signals such as signal X, Y, and Z, which having a data type of double. So coordinate X will be mapping to the signal X, coordinate Y will map to the signal Y, coordinate Z will map to the signal Z. Okay, so this is how the internal setup. Now let's look into the external signals. So we are looking at this external signal configuration. We have set up a TCP connections using this IP address and this port. Ambient is referring to the byte arrangement, whether it is the larger end come first or the smaller end come first. So you can find more about ambient when we are referring to the TCP bytes. Currently the status is unknown because we have not started the TCP server. So if I press refresh, it says reachable because somehow I did not turn off the server yet. So it is currently able to reach. So these 3 signals are the signals received from the TCP server. So each of these signals is a real type because we are trying to map to the coordinate system. Remember the coordinate system of the X, Y, and Z positions. So for each of the real data types, we are going to allow 4 byte spaces. So that means for each real type data, we need to allocate 4 bytes, so that it can represent a single precision number or a floating number. So therefore signal 0 is 4, another 4, and another 4. Total will be 12. So we need 12 space in total. And we do not have any receiving signal to the server. Therefore we did not put over here. But if you do have, for example, if you want to return the angular position for each of the robot joint, you can always add it here. So I'll just click OK for now. And for the X signal mapping, we are seeing that this signal 0 from TCP server we map to signal X, signal 1 we map to signal Y, and signal 2 we map to signal Z. So this is how the signals come to the software. So let me just quickly show to you the demonstration. I'll just quickly restart my server again. So I have developed a simple interface using Visual Studio, using Visual Basic Language to build the TCP server. So let me just quickly double click on this executive file. This is a simple dialog box to represent the TCP server. So I will quickly put the IP address, which is similar to the IP address. We are referring to the same IP address and same port. Enable. Then I'll click play. You will notice that there is no error because the connection to the TCP server has been established. Now remember that we have specified that there are 3 incoming signals from the server to the client. The client here refers to MCD. We are going to specify signal starting with signal 0, 1, and 2. So remember that signal 0 represents X direction, signal 1 represents Y direction, signal Z represents the Z direction. So let's say currently these are the current position of this point over here, and the positions are shown here as well. So let me just quickly show key in a similar value. So for example, this is the Z position, this is the X position, this is the Y position, and this is the Z position. And I'll click send. Notice that this value has been reset has been round up to this value, and also the robot actually does move slightly. So for example, in my design space, I have this point which is reachable by this tool center point. So I will just say I will just key in this value so that this tool will move to this point over here. So let's try to do that. 3, 5, 4, 198 and 55. Send. So you notice that it actually takes some time, and yeah, it went to this point over here. So I can definitely try to play around. For example, if I put another value, let's say I want to lower the tool center point in the Y direction, so I'll just reduce Y coordinate to 150. Yeah, you see that it is now over here, and this value has been mapped to the client software. So I will stop for now, and I will explain to you the methodology behind how can we build the TCP server, what is the conversions occurring at the background, and so forth. So first of all, I would like to show you I would like to introduce you to this software called Wireshark. So Wireshark is a essential tools in helping us to understand the TCP packet. So let me just quickly, you can find this Wireshark, which is open source, very easily. You can try to download and try to analyze the network package as well. So I will just quickly start up a new Wireshark session. So let's say this one. So the Wireshark network analyzer. So from here we are able to see which options is giving us a lot of traffic. So these are the possible network traffic. For example, I have Wi-Fi, and I also have this adapter for loopback traffic capture, which is applicable for my application. So I'll just click this one. So immediately from the Wireshark, I'm able to see a lot of information. For example, the source, the port information, and others. So because these are not relevant for the MCD application, so I'll just quickly do a filter. So my filter is, because I'm using TCP for my interface, so I'll just click TCP, and I also use the port 6000 to monitor the mapping of the signals through this port. So I'll be using the port and double equal sign 6000. Press enter. By doing so, I'm only filtering everything, all the events that is involving this port. So currently I only have one entry over here. So there is currently, we have not started the event yet. So let me just quickly start the event now. So you can try to play again. So you see that Wireshark is currently registering some information. Yep, there is a three-way handshake occurs between the server and the client to acknowledge the connections. Then we'll have, let's try to send some information. So I'll just using the same value over here, and I'll click send. Okay, so there is some error, so never mind, I'll just restart the server. One two 7.0.0.1. Enable and enable again. So from here, let's try to put this value so that the tool center point will move to this position, and while Wireshark is still running at the background, we are going to capture all the network packets. So 198.55 send. So now the tool center has been moved to this point. Now let's head over to Wireshark. So Wireshark, what are the information that is being displayed? So let's look into the last entry. You will notice that I actually sent the signal from the server to the client. The server is referring to this guy. This is the server. The client is referring to MCD. So therefore, we can have a quick look into the direction. For example, from 6000, port 6000 to 61,886. This marks the direction of the packet. This marks the direction of the packet. So this is the server sending information to the client, as well as this one. So we'll be just looking at the latest one, and then if you look into this bottom section, we have 4 rows of hexadecimal bytes. This 4 row represents the TCP packet. The TCP packet actually contains a lot of information. For example, we have the loopback, we have the header length, and etc. But what interested us the most is the data. So where is the data that we send? For example, we have sent 500, we have sent 354, 198, and 55. So where are these numbers? So if you try to look all the numbers here, it is quite confusing because we are unable to find these numbers yet. So if you look into this, the last segment, the TCP segment data, it contains 12 bytes. So 12 bytes actually is equivalent to the sending size. Remember that while we are trying to send the signal, while we are trying to configure the signal, we have this 12 bytes. Okay, sending 12 bytes, and then let's see. I'll just stop the online real-time capture of the network. So 12 bytes, then we'll note that there are 12 bytes over here literally 12 bytes. We can do the counting: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 bytes of data over here. And remember that we have specified 4. So if I come back here, we have specified 4 bytes for each real data. So come back to the Wireshark. So this 4 bytes actually represents the first signal. And then this 4 bytes represents the second signal. And lastly, the last 4 bytes represent the last signal. So we have some hexadecimal value, and we are going to convert this value into the single precision number or floating number or just a double number. So let's try to verify this information. So I have a very convenient website called this greystole.com. So you can hover over to this site, and then we can quickly use the online calculator to verify this information. For example, the first one, let's put in 43B10000. That will be the 4 bytes information over here, convert to float. So we are getting this 384. So 384 is the information that we have specified in the first portion of this array. Now let's try to verify the second information. So that will be 4346000. 0000, which is equivalent to 4346. Sorry, 4346. Convert. Okay, 198. Lastly, 425C0000. Okay, so 53 and 53. So that is to say, NX MCD requires the data. Firstly, this is the incoming signal, the incoming input to the TCP server. The server will need to convert this information to extract the 3 numbers shown. So this is actually in string data type. The string data type we need to convert into single precision or double data type in Visual Basics, and from single precision or double type convert into 4 bytes hexadecimal values. And that's the reason, that is how we are able to get this 4 bytes value, and we are sending 4 bytes value to NX MCD to do the virtual commissioning using TCP connections. So also I will include the program files. So this is the source code that I'll be using for this form. So I will include this form into the download link, into the description link below, so that you are able to refer and build yourself the connections. So thank you, and I hope you enjoyed this video. See you next time.